Solve the differential equation d raised to 4 plus 2d square plus 1 acting on y equals x raised to 4. We have a non-homogeneous type of differential equation with the RHS x raised to 4 which is of the form x raised to n. In order to find out complementary function, we have auxiliary equation equals m raised to 4 plus 2m square plus 1 equals 0. This is of the form m square the whole square plus 2 times m square multiplied to 1 plus 1 the whole square equals 0, which is of the form a square plus 2ab plus d square, where you can consider a equals m square and b equals 1. Hence, auxiliary equation can also be written as m square plus 1 the whole square equals 0. This auxiliary equation consists of 4 roots which are plus minus iota plus minus iota. That is, we have imaginary roots which are repeated. Imaginary roots will be written in the format alpha plus minus I times beta, and here we have alpha equals 0 which is the real part of the root and beta equals 1 which is the imaginary part of root. Complementary function will be of the format e raised to alpha x multiplied to c1 plus c2x multiplied to cos beta x plus c3 plus c4x multiplied to sin beta x. It is exactly same as e raised to alpha x multiplied to c3 plus c4x multiplied to cos beta x plus c1 plus c2x multiplied to sin beta x. Here we have alpha equals 0, hence e raised to alpha x equals e raised to 0x equals 1. Therefore, when you give beta equals 1, we are obtaining complementary function as c1 plus c2x multiplied to cos x plus c3 plus c4x multiplied to sin x. Now we will find out particular integral. We have 1 by f of d acting on the RHS x raised to 4, where the operator f of d equals d raised to 4 plus 2d square plus 1. You can also write f of d, which is d raised to 4 plus 2d square plus 1, as d square plus 1 the whole square, which is directly following from this equation. When you replace m using capital D, you obtain f of d equals capital D square plus 1 the whole square. Now we have pi equals 1 by d square plus 1 the whole square acting on x raised to 4. Whenever you have RHS equals x raised to m, we will try to write 1 by f of d as equal to 1 plus g of d, the whole inverse which acts on the RHS x raised to m. Since we have f of d equals d square plus 1 the whole square, when it is taken to the numerator, it becomes d square plus 1 the whole square, the whole inverse which acts on x raised to 4. That is, we have pi equals 1 plus d square the whole raised to minus 2 acting on x raised to 4. We can easily expand 1 plus d square the whole raised to minus 2 using binomial expansion. Since we have 1 plus y the whole raised to minus 2 equals 1 minus 2y plus 3 times y square minus etc. We have 1 plus d square the whole raised to minus 2 equals 1 minus 2 times capital D square plus 3 times capital D raised to 4 minus etc. So this is the operator which acts on the input x raised to 4. 1 multiplied to x raised to 4 becomes x raised to 4 itself. Capital D square acting on x raised to 4 equals derivative of x raised to 4 taken 2 times. That is, x raised to 4 whose derivative is 4 times x cube is again differentiated with respect to independent variable x. Hence we obtain capital D square acting on x raised to 4 equals derivative of 4 times x cube, which equals 12 times x square. Similarly, when you wish to find out capital D raised to 4 acting on x raised to 4, you have to evaluate capital D square acting on the output of capital D square acting on x raised to 4. That is, d raised to 4 equals d square multiplied to d square. In order to evaluate d raised to 4 acting on x raised to 4, it's enough to operate capital D square on this answer, because this answer is already equal to capital D square acting on x raised to 4. Hence we have capital D the whole raised to 4 x square equals capital D square acting on 12 times x square. You take the derivative of 12x square again 2 times. Derivative of 12x square equals 24x. Again, when you take derivative, it becomes 24, which is a constant. Notice that power of x is 4 here, and we have neglected higher powers in the binomial expansion, because those powers of capital D When operated over the input, x raised to 4 will yield 0 as the answer. Now we have found capital D square acting on x raised to 4 equals 12x square, and capital D raised to 4 acting on the input x raised to 4 will give us 24 as the output. Thus we have Pi equals x raised to 4 minus 2 times 12x square plus 3 times 24, which equals x raised to 4 minus 24x square plus 72. Hence we have the required general solution y equals sum of complementary function and particular integral.